introduction of the third axis, and we end up with 3 planes. There's lots of ways to visualize it. We have this model. You can visualize the floor as being one of the planes, this wall here being a plane, and this wall over here being one of our planes. So the edges where these planes meet, this crack along the floor, this right here along the floor in the wall, and then this one end up being your axes. This room that you're in, if that would be where we were referring to as these axes 1, 2, 3, this room right here is where everybody is positive. It's like quadrant 1 on graph paper. We got positive, and we got positive. So you're right, you're forward, and you're up, all positive directions. So when you name a point, we name the points x, y, z. X, y, z. It would be called an ordered triple. And any ordered triple that works in a linear equation is called a solution. And if we're talking about a system of linear equations, if it works for all of them, it's called a solution for all or for the system. Now the problem is harder to get a solution to a system when you're graphing in 3 variables. Here's a couple of examples. The red, green, and blue planes, how many solutions do they have? Just one. There's only one point where they all meet. And that point is the only point that's on the red, the green, and the blue. If they intersect like pages in a book, so the red, green, and blue planes intersect along this line, then you have an infinite number of solutions. Okay? There's an infinite number of solutions, but not necessarily because they're the same line or same plane. It's because they intersect in a line which has an infinite number of points on it. You have this kind of a situation where there's no solution. You have red, green, and blue. There's nothing that's red, green, and blue. You have red and blue this line, red and green this line, and red and blue this line, but there's no points that are red, blue, and green. So you have, if you were looking down, you'd have this triangle of shapes here. And you can see here you have 2 planes that are parallel with the red plane. Nothing's going to be red, green, and blue, and these 3 parallel planes have no solution also. I don't know, did I not? It's a good question. Yes, I did. Thank you. More? Here's what you need to get out of this page. X, y, z. Honestly, this right here is the most important thing on the page. All the abstract, the visual is great, but I want you to know that we're naming points now with 3 coordinates, an x, a y, and a z.
So x goes like this, y comes towards us and away from us.
X goes towards you, y goes left, right, and z is up, down. And I'll show you that in a second. We'll put up a coordinate plane for you. We're not going to have to worry about that. That detail in this class, unfortunately, is too specific. And for our purposes, we're going to work only algebraically with these. They're tough to graph. I'm going to show it to you real quick just so you can see it. We will not graph these at all. Yeah, we're only going to do this for a day, so we don't get into it. We used to spend a lot more time on this. This is a linear equation in 3 variables. Who can tell me why we would call this linear? There's a reason why we say this is a linear equation. And you know this reason. Because? Well, that would be why it's in standard form. A, B, and C, and D have to be integers. A is positive. But that's not what makes it linear. All the variables, the x, the y, and the z, are raised to the power of 1. None of them are multiplying, none in the denominator, none under a radical. That's a linear equation by definition. This is standard form. AX plus BY plus CC equals D. A, B, C, and D are all integers and A is positive. A, B, C, and D are all integers and A is positive. This is an example, real simple one. 2x plus 3y plus 4z equals 12. 2x plus 3y plus 4z equals 12. There's an infinite number of solutions to that equation. When you were going to graph it, you would actually get a plane. It's not really that important. Any solution to this equation is called an ordered triple x, y, z. Somebody give me an example of an ordered triple. It's a solution for this equation.
6.4
Your thinking is good, but what if you plugged in 643? Would it make a true statement? You're overthinking it. Give me the one that would be. Give me, I want to do an ordered triple so that when I did plug it in, it would make it true.
003.
003. What did you just find when you choose that particular one? I wasn't expecting. Huh?
I found Z
The Z what?
variable.
Yeah, but 003 is not a variable.
It's a coordinate.
This is the Z intercept. So 003, this point right here, on the Z-axis, because you go left, right, you go front, back, nothing, left, right, nothing, and you just go up 3, that's the Z-intercept. You were kind of finding all 3 intercepts in one shot from your first one. That was pretty good. Give me another point that when you plug it in would be a solution, right?
600.
600, and that would be called the x-intercept. And
040.
040 would be the y-intercept. And then, hopefully you could come up with other points.
But that would make a line though if it was like.
No, in 3 dimensions, a
Like a
linear
triangle.
equation graphs a plane.
Oh, okay.
So yes, it would make a triangle, but it would also connect all the points, and it would go like this forever. So there would be negatives and positives, and it would give you a plane, not a line, even though it's linear. And that right there kind of makes you go, oh God, I don't get this. Don't worry about the visual. Okay? We're going to be doing the elimination method only to solve systems with 3 variables. Okay? We're not going to do substitution typically. I'm going to show you one where you can get away with substitution, but all the other ones, you just need to do elimination method. Okay? That's a 2-dimensional representation of the point 6, 10, 12, where you start here, you come out 6, you go right 10, and up 12. It's very hard to show a point in space on a 2-dimensional plane. You don't have to worry about that. This is called the box way to show that. Again, you don't have to worry about it. What you do have to be able to tell me is there a solution to this system? And if there is it infinite? Is there a point solution? Or potentially you could have a no solution. Plan on quite a bit of space on this. Plan on super organization. And I promise you, if you try to be organized, you'll be successful. I can tell you, those of you who are all over the place with your stuff, you're going to have a very challenging time getting through this. Okay? Again, you're going to typically see, for me, you're going to see me make a border over here, and I'm going to call this equation A, B, and C, because these can get away from me fast, and I have a hard time sometimes going back seeing what you're going to do. In the elimination method, you need to eliminate one of the variables twice. Right? So we're going to pick one of our equations.
Why?
I'll explain in just a second. Bear with me. That's a great question. Why do we have to do it twice? We did it. Why can't we just be done with it? That's a great question. Bear with me. So we're going to eliminate one of the variables, and it doesn't matter which one. And you have to do it twice with two different equations. So I'm going to say, let's do the x's. Okay, we could do the x's. And I'm going to get rid of the x's, and I'm going to multiply equation A by -3. So -3 times equation A is going to equal equation D. So if I multiply -3 times this equation, I'm going to get -6x. I'm going to get plus 3y minus 18z and a positive 12 on the other side. Don't forget to do the other side. That's the big common error. Notice that the second equation already has a 6x in the x spot. So now I have opposite coefficients. So this is equation B right here. This is equation D right here. I'm going to go ahead and add equation B plus D and get E. The x's are gone. We have 7y minus 23z is equal to 5. Why do I have to do this twice? Because I can't solve for z or y here because I don't have enough information to get a z or a y. There's two variables. So what I'm going to do is I'm going to go back and I'm going to get rid of the x's, but I'm going to use equation A and equation C this time. So what do I have to multiply equation A by so that I'll be able to get rid of the x's?
So 2.
Just a 2. So we're going to do 2 times equation A, and I'm going to call that F, and that's going to give me 4x minus 2y plus 12z is going to equal -8. So that's 2 times equation A. And I'm going to add that to equation C. So this is equation C. So we're going to do F plus C is equal to G. The x's cancel. I get -4y. I get 17z and 1. So here's one equation right here that has just y's and z's. Here's another equation right here that has just y's and z's. I'm going to use equation G along with equation E, which is 7y minus 23z is equal to 5. Which variable should I get rid of now? Yeah, y. Either way, it's going to be kind of a challenge. We're going to multiply 7 times equation G, and that's going to give you equation H. You're going to get -28y plus, what's that?
Well, don't you want to get rid of the y, so you have to leave that one positive and keep the other 3. Oh, wait. What? What do you mean -28y?
7 times -4 is usually -28, I think. I'm multiplying 7 times this one and 4 times this one. Your thinking was right. Remember, this is 17. So 7 what is that, 119? And 7. And then 4 times e is going to give me 28y plus 68z and 4.
Isn't it minus 60?
Oh, sorry, I did the wrong equation. I did the whole top. I did the top. So 4 times negative 23 would be negative 92z, and 4 times 5 would be 20. Good catch, thank you. Is the 92 right?
Yeah.
92. So now we're going to add the h and the I. The y's are gone. Is that 27? 27z is equal to 27. You'd have to check me on that. And the calculator. We now only have one variable. What does that mean? C equals 1. Where should I plug it in? That's exactly right.
Into G.
Into either G or E. Either one that has only the 2 variables. So we could do this one. So it's negative 4z. Negative 4y, right? Negative 4y plus 17 times 1 was equal to 1. So negative 4y equals negative 16, and y is going to be 4. Now I know what z is, and I know what y is. Where do I take those? One of the originals. So we can go back to A, B, C, doesn't matter which one. So A looks good. So let's do this. Put that back down at the bottom. So we're going to put in for y, we're going to put a 4. In z, we're going to put a 1. So 2x minus 4 plus 6 times 1 is equal to negative 4. 2x plus 2 equals negative 4. 2x equals negative 6. X is negative 3. What does that mean?
We have all three.
So what should I say?
TS, TTS.
Negative 3, 4, 1, negative 3, 4, 1. Now, listen to this question. Did we do anything really that was that difficult? Did we do something that takes 5 minutes? Yeah. And anywhere along this path, you screw up one negative, and it's like you push that domino and you go, brrr, and it's all over. You may mess up one addition, one subtraction. That's why I'm telling you, you want to be very meticulous. Now, we know the solution to the system is negative 3, 4, 1. You can check it by plugging those into these 2 equations and verifying 6 times negative 3 is negative 18 plus 16 is negative 2. Negative 2 and negative 5 is in fact negative 7. So you get some corroboration.
Can you look at how you got y again?
How I got the y value?
Yeah. What?
You understand how I got to z is 1?
Yeah, I got that.
See the 2 yellow equations?
Yeah.
Take z as 1 and plug it in for z in one of those. That will leave you with just y as the unknown.
Yeah.
And
So,
I plugged it into,
so wouldn't it be negative or?
I plugged it into negative 4y plus 17 equals 1. When you subtract 17, you get negative 16 and negative 4y.
Okay, yeah.
And then dividing by negative 4 gives me a positive 4.
Right.
Sorry, I probably colored too quickly.
Right.
Yes.
Scroll up to E plus F.
Higher? Oh, okay. Okay? Write them down so you don't get a carryover mistake. When we add A and D, the X's are gone. You have your 8y, you have minus 7z, and you get 29. So there's your first equation that only has 2 variables in it. That's your first step accomplished. Now you have to go back up and you have to use equation C with either A or B, and it's going to be easier to use with B. So what do I multiply equation B by this time? Negative 3 times B, and you're going to get negative 6x, positive 9y, negative 15z, and a positive 42 on the right. Again, C, 6x minus y plus 4z is equal to negative 1. If we add f and c, the x's cancel. This time it's 8y, it's a negative 11z, and it's 41. So there's your second equation with 2 variables, y's and z's only. This now becomes the system that you solved last night. If that makes sense. This is what we did last night, 2 variables, 2 equations, easy. But it took you all of this to get to last night's homework. Okay? If you don't have the assignment written down, this is your assignment. Please print the September calendar as well and bring that into class on Tuesday. Right now, something to write with, calculator, everything else, clear your desk.